Okay, greetings and salutations. Unit 3 review, and then after you take this test, we're at the end of Unit 4 too. That's what I boat raced through. I covered that in like 2 days. Round each of the following numbers to indicated number of decimal places. So you got 3 decimal places. That's the 3rd place. Well, then the 9 becomes a 0, and the digit before it goes to a 1. Okay, so to take a 9 up 1, you put 0, and then that becomes 1. So you have 0.010. You can put the 0 or you don't have to, and then you drop everything after that place. If you put 0.01, I know for a fact I don't care about that. Okay, 4 places, 1, 2, 3, 4. There's your 4th place, and that's going to go to a 1. Everything after it's dropped, everything before it I write down, 3001. Express each fraction as a decimal, round to 3 decimal places if necessary. You just divide it. You got to round the 3rd decimal place. I'll actually show it on paper because it's hard to see on my couch. So if I have to round 3 places, I need to write out 4, 1666. So you have to round to the 3rd decimal place. Well, that's going to a 7. Drop everything after it, 0.167. 1732, again, you just divide 17 by 32. Okay, if I have to round 3, I need to write 4 down, 0.5312. That is going to stay a 1, so everything else is just dropped, 0.531. Okay, now you're taking a decimal and making it into a fraction. Make sure each fraction is reduced to lowest terms, okay? So you write the number 625, and you got to decide what's your final place value. So after the decimal, it goes tenths, hundredths, thousandths, 10,000ths. So it's 625 over 10,000, and you can reduce that. You can use it, try the ABC first just to save time. 1/16, okay? Now if the ABC gives you decimal, then you got to start dividing, okay? You divide by 5, then see if you, I would use 2357, okay? That's the ones I would go with. Okay, 0.058, so you got the number 58, tenths, hundredths, thousandths. Here's an example of what I'm talking about, okay? Of if I got a decimal. I don't think that one is, okay? As a matter of fact, I know it's not. Yeah. Here's what you do, okay? You list a bunch of your prime numbers. Can those divide by 7? Really the only way to see is if, nope. How about 5? Nope, that has to end in a 5 or 0, okay? 3. One way to know if it's 3 is you can add the digits. 5 and 8 is 13. Does 13 divide by 3? No. But they're both even, so you can divide by 2, and that would be 29 over 500. Now, can you divide by 2 again? No, because now 29 is odd, so you stop there. Again, you don't have to do it that way. I'm just explaining what you'd have to do is if... Then I'm not going to insult the intelligence of the class by punching numbers into my calculator. I think you're capable of that. Skip. Not on the test. On the test you got to do them. There's more of that. Skip. By the way, so if anybody's questioning, well, he's just showing it because he don't know how to do it. Well, what you'd have to do is take out the decimals and take 13 times 27 times 9 times 23. Then you'd move after you got your product, you move the decimal back left 1, 2, 3, 4, 5 times. That's how that works, okay? But, yeah. Now, when you multiply by 1,000, obviously no one's going to stop you from punching in your calculator, but when you multiply by 1,000 or 100 or 10 or any base number of a base 10, a power of 10, you can really just move the decimal 3 times forward. So you'd move it once, 163, twice more, it'd be 16300, 16,300. 100, that would be 0.3. Again, the decimal just moves forward twice when you're multiplying by numbers like 100, 1,000, 10,000. Okay, I'm not going to insult the intelligence of the class by doing this. Okay, these four, I'm not going to waste your time. Also, for those questioning, oh, Hermson, he's doing the calculator because you don't know how to do it. Nope, here's how you'd have to do it if you didn't have a calculator. You'd have to move the decimal twice. This would be the insight. You have to move it 4 times to the end so you don't have a decimal. 906,059, and then you'd have to move this the same number of places, 1, 2, 3, 4, and that would be 20,090, and then you'd have to divide that using long division. Okay, and the decimal wouldn't come back; it would just stay out. But again, no. Now, when you divide by 100, by numbers like 1,000, 100, then the decimal goes this way, 1, 2, 3, okay, so that would be 0.079501. Raise the following numbers to the indicated power, 2.2 to the third, that's a decimal, it's not 2 times 2, 2.2 times 2.2 times 2.2. Or you can go 2.2 to the third power, 10.648. If it doesn't say to round, roll with that. That's just 0.008 times 0.008 or 0.008 raised to the second, and that's what you get. Okay, now before you do your power here, you got to simplify it in the parentheses. That's 0.25, and then 0.25 times 0.25 is, I think it's 0.0625. We'll see if I'm right. Yep. Okay, 5,000. I'm going to entertain myself and do some mental math here. So that would be 5 times 0.2. Is it 1? Darn, I'm good. Okay. No, see, and there's no paper around here where I'm looking at like I do it normally. 1 to the power of 4 is 1. Okay. 1 to the power of anything's 1. Okay, finding the roots. That's a square root, means what times itself is 225. Now you can play around with it, or you can just square root it on your calculator, because I think most people in here, especially since we have a bunch of people in this class that have taken trig, probably know what a square root is. Okay, 15. I'm really not. By the way, to do that, it's go second, x squared, and then the number you want. Cubed root's different. Now, this one's a pretty easy cubed root. What times what times what's 8? 1 ain't 1. I think it's 2. Now to do that on a calculator, you have to do it completely different. When it's a higher root than a square root, you got to go 3, second, caret button, 8, this. This is what you don't do. 3, second, x squared, 8. Yeah, that ain't even close, okay? Because that means you're taking 3 times the square root of 8. That's not what you want. You want it the cubed root of 8. So 3 second caret 8. Once again, there's square root and there's cubed root. Or 4th root, 5th root, whatever. Make the distinction. Okay, 3 times 12 is 36. Square root of 36 is 6. 101.7 plus 23.3 is going to be 125. Then the 4th root of 125, so 4 second caret. It's got to be done like that when it's higher than a square root. Round, oh, they didn't tell me what to round. I don't really want to write that whole thing out. If they didn't give you a rounding and you end up with an irrational root, you're going to write just round it that many decimals. Okay, the cubed root of 87.705, round to 3 places. So 3 second caret 87.705. 3 decimal places, so it'll be 4.44 and then 3. And they want that one rounded. Now that's a 4th root rounded, okay? This is a pretty easy test, we're not gonna lie. 1.7, 1.7, or it go 1 decimal place, 1.8. Okay, now here you have order of operations. You need to calculate your 4th root first, okay? You need to get rid of that. So 4th root of 50.35. Again, go 2 decimal places if they don't tell you, 2.66. So now we have 0.848 minus 0.035 times 2.66 divided by 8.25. So we have minus, times, and then division. Well, obviously you're going to have to do the division first to figure out what the heck that is, okay? Because it's a fraction, so. Okay, round that off, 0.32. And then after the division, then minus and times. Times holds a greater value, okay? Now, some of you might be like, well, might be thinking, well, don't you times first because that comes first? No, if it's a fraction, if it's on a fraction division line, that means that holds the highest value, that operation does. And I times 0.0035 times 0.32. Then you just subtract. Remember, adding and subtracting holds the least value unless it's in parentheses, so 8.47888. There is a way to punch that into your calculator in one fell swoop, but I'm worried a lot of people will mess it up, so I'm just going to. Remember, those roots are like exponents, okay? You figure them out first, then you do your fraction, then takes the highest, okay? And then we just divide that. Then times, then minus, that's the order. Okay, story problems. Okay, 32, the inside width of an air duct this is what an air duct looks like, by the way. It's very similar. It looks like a pitcher with a frame. Not really if you see it up close, but that's kind of what it looks like. You got the inside width is 8.48. The duct is made of 26 gauge metal. The 26 has nothing to do. That just tells you what kind of metal it is. They're trying to throw that in there to trick you. And that's 23 thousandths of an inch thick. So you got the metal on the outside, okay? Again, if you're not if you don't deal with that kind of stuff, you're not going to know what that stuff means. So that's the inside width. And then the metals are on the outside, and it's 0.023 on each side. Just like most of these problems, the math is not hard. It's just knowing what the heck they're talking about. Find the outside width of the duct. Well, now you just add them. You take 8.48 plus 0.023 plus 0.023, 8.526. And it's just a straight, you just measured a straight line, so the label is inches. Okay, 33, this looks harder than it is. The part shown, which is dimensioned in centimeters, to be made by a machinist. 18 equally spaced holes are drilled along the length of the part. Find in centimeters the total length of the material needed, so centimeters. Now, the question mark's what you're finding. So you have the outsides, which is 3.18. You can either add another 3.18 or just multiply it by 2. Means the same thing. Then you start into your holes that are drilled. And between each hole, every space between the center of the holes is 1.54. Now, this thing being broken up means that you don't see the whole thing, okay? Like the writers of the textbook just didn't want to make the whole thing. It being broken up like that means, in like technical problems, it just means there's a bunch of holes in that little space that you don't see, which is obvious because it says there's 18 of them. That ain't 18 holes. So there's a bunch of them that they cut out of the diagram and you don't see. Now, you have to multiply that by something, because obviously there's going to be more than one of those 1.54 spaces, and you have to know the rule. There's 18 holes, so there's one less space than there are holes. So you'd multiply it by 17, not 18. So you have to multiply that first. Okay, so all the holes are 26.18 centimeters. Then you just add those outer dimensions. $32.54. Okay, next, this one's an easy one. The length of the sides of a square or a cube are given in the table shown. Find the areas and the volumes. Round your answer to one decimal place. Here's a tricky part. One of these you're going to put NA, and one of them you're going to find the answer. Okay? Or actually, no, that's a different problem. My bad. Okay, so the areas of the front surface, that's just the area of the square, okay? Not three-dimensional. So what you're going to do is simply take the 2.24 to the power of 2, because the area is just the length times width, but since it's the same thing, you raise 2.24 to the second power. Okay, round to one decimal place would be 5.0. And they didn't seem to give me labels, so... Okay, this is the same. And then to find the volume of the cube, now you would find the three-dimensional. So you'd raise 2.24 to the power of 3. Because volume's length, width, and height, but since they're all the same, I'm multiplying three factors that are the same. I use a third power. Okay, that's 11.2. Okay, we're just repeating, you just repeat the process. 35.20 to the second is 1,239.0. Then 35.20 to the power of 3. 43614.2. Okay, now they give me some labels. On these, I know they want labels. 0.50 to the second power. 0.25, now that would then go m to the second, meters to the second. M is meters, mi means miles, okay? And then if I raise 0.50 to the power of 3, I get 0.125, and that would be my label to the third power. Okay, 10.2 inches, so 10.2 to the power of 2 is going to be 104.04 inches squared. And 10.2 to the power of 3 is 1,061. Oops, that was too many decimal places. That'd be 0.0. Again, that would be 0.3. I screwed that up. I forgot I was rounding 2 decimals. That'd be 0.1. 1 decimal, sorry. Forgot about that. 1,061.2. All right, now on the next one, you're going back the other way. If it says ignore, that means you don't find that, okay? So the areas of the front surfaces is 45.23 square feet. So you need to now go backwards and find what the sides are, okay? You don't take it to the second power because this has been taken to the second power. This is what we got. Then to go in reverse, you find the square root of that. So I find the square root of 45.23. So that's going to be 6.7. And now it's just feet. When you're measuring a straight line, just side length, it's just feet. Because that S you're coming up for is a straight line. Okay, now if they give you the volume, then you just cube root it to get to the side length. So you go 3 second caret, 30.45, 3.12. Then it's down to meters. Okay. The area to get to the side length, I square root. It's It's like the opposite of the second power, which is a square root. We learned that in algebra class. Okay, 1 point. God dang it, I keep writing 2 places when they want 1. 14.3 centimeters. And if it's cubic, to get it to find it, we just do the opposite of the third power, which is a cubed root. So 3. See, because we want to get that cubic feet to the third power into just feet. Okay, 4.03, or 4.0, I guess. Okay. All right, so remember how that works. Now, this one here, just got to keep your head on straight. It's a bunch of squares. A landscaper is to landscape the shaded area of land around the office building shown. The landscaper charges 5 cents per square foot for this job. Find the price charged to complete the job. So the price they give us is 0.05 per square foot. So that means times the square feet will give me my cost. But I have to figure out how many square feet there are. Now, look at the whole thing. You have 2 squares. This is a square. The outer dimensions are each 120. So the square feet would be 120 to the second. And then this square, the dimensions are 100 by 100. So that'd be 100 to the second. But then you got to subtract that building in the middle. So the building's also 2 squares. Well, the square's dimensions there are 40. So minus 40 to the second. And the dimensions here are 50 to the second. So you're adding the two outside squares, but then you're going in and subtracting those. So I take 120. You can just do it on a calculator. Okay, and we got 300 square feet. So now I can easily find my cost. 5 cents times 300 is, I believe it's 15 bucks. Okay. That's pretty cheap. Did I do that right? That seems awful low. 120 to the second plus 100 to the second. I might have screwed this up. Yeah, I was going to say 20,300. Yeah, nobody's going to do a job like that for 15 bucks. Okay. So 0.05 times 20,300, $1,015. That's more like it. I got a contract with the landscaping company to do something for $15. Okay, then you got this little thing. It's like it's like the Pythagorean theorem on steroids, basically. I'm not going to waste time explaining how that became. I'm not even really sure if I could. Main Street, 2nd Avenue, and Maple Street intersect as shown. The shaded triangular portion of land between the streets is to be used as a small park. In finding the cost of converting the parcel of land to a park, a city planning assistant computes the area of the parcel. Sides A, B, C of the parcel are measured. You have to find the area. That's the formula you're going to use. So B divided by 2. So it's going to be 34 divided by 2 times the square root. And you got a lot of stuff in the square root. A to the second, so that's 72 to the second. C to the second is 93 to the second. Minus A to the second, 72 to the second. Minus B to the second, 34 to the second. Divided by 2 times B, so 2 times 34. And don't forget there's a second power outside of there. So let's simplify. That's going to be 17. We can probably take 72 to the second. Okay, that'd be 5,184. Now what about that parentheses? Well, I'm going to simplify the top. 93 second minus 72 to the second minus 34 to the second. 2,309, and on bottom 2 times 34 is going to be 68. So I'm going to take 2,309 divided by 68. You're simplifying that parentheses. You want to get rid of that. 33.96, okay? Round, if they don't tell you what to round to, just go 2. To the second power, don't forget about that. So I'm just going to figure out what that is. So 5184 minus 30. Now I'm going to figure out what goes inside the square root. Before I square root, I need to find the one number that's inside of it. To the second power, and that's going to be 4030.72. Again, you can do that first, then subtract. If you punch it all in on your calculator, this little thing, it will do the second power first before subtracting. So 4030.72. Now I need to find what the square root of that is. Okay, 63.49. So we have 17 multiplied by 63.49. Okay, 1079.33. If you're wondering about the label, you just found the area. It says it's square meters, so you can just put m squared. Okay, so again, I lined them all up. Okay, some of this stuff I did on the spot. 17, I raise that to the second. The parentheses, I figure the top, figure the bottom, and divide. Still to the second power. Then I would raise that to the second and then subtract that from there, but I just punched that into the calculator and it did it for me. Okay, and then I square rooted that.